welcome to the Congruence Transformations podcast. All right, so this is in your notes, so follow along with me, complete your notes. All right, so first thing we're going to do is we're going to use the congruent statement. Triangle JRB is congruent to triangle MNS, and we're going to identify our congruent angles and our congruent sides. What makes it nice and easy is our congruent statement tells us what our congruent angles and sides are, so we just have to match them up. So notice that J and M are in the first position there. That means that angle J is congruent to angle M. And R and N are in the second position, so that means angle R is congruent to angle N. And finally, B and S are in the last position, so angle B is congruent to angle S. So even without triangles to look at, we can still identify our congruent parts just from our congruent statement. All right, so now let's identify the congruent sides. Same thing. For sides, those are line segments. We need 2 points, the start and end. So all we have to do again is look at the position. So JR and MN are in the first two letters in both of those triangle names. That means that JR, segment JR, is congruent to segment MN. And I'm actually going to just show that they're segments. And then if we look at the last two, those segments are also congruent. So RB would be congruent to NS. And then finally, right, so if we continue around the triangle, these two segments will also be congruent. So SM is congruent to EJ. And there we go. We've named all of our congruent sides and angles. It was just that easy. All right, so let's look at the next problem in your notes. Had this one hidden just so you wouldn't look at these triangles when you were trying to name the congruent parts in triangles that have nothing to do with these triangles. All right, so we're going to analyze the two triangles shown. So let's see if we can figure out which are the corresponding angles, which angles might go together if they are congruent, and then are the triangles congruent? Is there a transformation that maps TWO to the other triangle? So I kind of noticed, you can look at how the triangle looks and see which sides seem to go together. Like WT here appears to be the longest side, so that probably goes with what looks like the longest side on the other triangle. PM, maybe those go together, so maybe WT goes with PM. But also look at those coordinates. So let's write those down actually, because we're going to use those afterwards, because we're going to figure out a transformation that maps one triangle to the other to show that they're congruent. And this problem is also in your notes. So W here is at -9, 4. T, I may as well go in order the way I have it written above. Point T there, is at -1, 6. And I put O when I was typing it up. That C looked like an O to me. So let's just call it O. All right, so O there is at -4, 3. Now if I look at the other angles, all right, so let's look at P. P is -6, 1. Well, that seems to go with this angle here when I'm looking at the coordinates. And it seems like perhaps P and T do look like they might go together. All right, so if I look at K here, K is at -3, 4. Well, maybe K goes with this angle here, which also has 3's and 4's in it. And W, therefore, -9, 4, maybe that goes with M. So if I'm not sure by looking at it, once I look at these coordinates, I think I kind of know which angles should go together. Because I definitely think O and K are the largest angles, but it's kind of hard to tell between P and M and W and T, who's larger, who's smaller. But when I look at these coordinates, I don't have any doubt who goes together. So the corresponding angles, I think, are angle T and angle P, angle W and angle M, and angle O and angle K. All right, so now let's see if there is a transformation that maps triangle 2 to triangle PMK. Well, notice that the coordinates are just switched, right? So instead of 1 and 6, we have 6 and 1. Instead of 9 and 4, we have 4 and 9. Instead of 4 and 3, we have 3 and 4. And notice that some signs have changed as well, right? So if we switch -6, -1, 6, we should have 6, -1. And notice instead our signs are a little bit different, right? So if we've got switching, if our coordinates are switching and our signs are changing a little bit, then what we must have is a rotation, right? So, and we look here, this does look to be rotated, right? They're not mirror images, they're not facing the same way, and this is a rotation. This is a rotation 90 degrees, right? So we have a 90-degree, and if TWO, if we're mapping TWO to the other triangle, that means we're going this direction. We're going counterclockwise. So 90 degrees counterclockwise about the coordinates that are just switching places. That's about the origin. We wouldn't get that if we were rotating around some other point, because our coordinates are only distances from the origin. Oops, and I forgot to write the word clockwise, rotation. We have a 90 degrees clockwise what? Rotation about the origin. So add this to your notes. And now we were asked to determine if these triangles are congruent. So let's answer that question. So 90 degrees clockwise rotation about the origin. All right, so add the following to your notes. All right, so since there is a sequence of rigid transformations that maps triangle TWO to triangle PMK, triangle PMK. And you should always state what the congruence, what the transformation is. You can state it in your justification, or you could state it separately like we did here. All right, so now we've answered that question. Gee, that wasn't too difficult now, was it? Let's do one more question, and then I'll have a couple questions for you to answer. Any day now, my question. And here's my question. All right, so we're going to analyze the two triangles shown. We're going to determine the transformation used to create triangle ZQV. All right, so now let's look at our coordinates here. All right, so if we're creating ZQV, this one must be the image, and this one must be the pre-image. All right, so T here is 4, 9, and Q and Z here is 4, -9. G is 3, 4, and V is 3, -4. And finally, R is 6, 1, and Q is 6, -1. Well, which of our transformations would keep the x value the same and change the y to the opposite? That is a reflection about the x-axis. Or you could say, or y equals 0. And this one, by the way, is also in your notes. Does the transformation preserve the size and shape of the triangle? Well, we'll take a look at those. Are they the same? I will tell you they are. Yes. Why or why not? Okay. I'm going to actually just end my sentence here. Just put yes and start a new sentence. A reflection is a rigid transformation. We talked about that at the very beginning of this whole lesson on Tuesday? No, Wednesday. Reflection is a rigid transformation. Rigid transformations preserve size and shape of figures. Size and shape. I just put size and shape. Right? So if we can map one figure to another using a rigid transformation, then the figures have to be congruent. We want to write a congruence statement for the triangle shown. So maybe I'm going to write triangle GRT. Great. If I write triangle GRT, then I have to say the triangle congruent to that would be triangle V goes with G, Q goes with R, and Z goes with T. Right? V, Q, Z. Right? And this is the end of this particular podcast. I have some problems for you to answer. Some of them have an image that goes with it. Make sure you check for the image, and I'll see you in the next podcast. One more podcast, actually.